Alright, let me write this down. 6, 10, 12, 12, 10. 6 to go to 10 is 4, 10 to 12 is 2, 12 to 12 is 0, and 12 to get to 10, subtract 2. The difference, 4 to 2 is negative 2, 2 to get to 0 is negative 2, and 0 to get to negative 2, you subtract 2. Now, I'm going to half that. Half of negative 2 is negative 1, so I'll put it like this. First 5 terms in this sequence, negative 1 n squared is negative 1, negative 4, negative 9, negative 16, negative 25. Put that in parentheses, because now we're going to subtract 6 minus negative 1, which is positive 7. 10 minus negative 4 is 14. 12 minus negative 9 is 21. 12 minus negative 16 is 28. And the last one is positive 35. So our expression, and our nth term, is already negative n squared. Now you notice that there's another sequence in here, right? After we subtracted the quadratic part of it, we are left with this sequence. Well, I'll start again. This is plus 7, plus 7, plus 7, plus 7. It's a 7 n sequence, so in front of the n, we found the coefficient, which is n. This is your slope, right? So 7 times 1 is 7, 7 times 2 is 14, 21, 28, 35. Notice that I don't have to make any adjustments to this to get to 7, the 7, 14, 21, 28, 35 that is in red. That's why we have, when you subtract 7 minus 7, get 0, 0, 0, 0. So our final answer is negative n squared plus 7n. Alright, so G, I think we're doing G. Well, 9 to 4 would be subtract 5. 4 to negative 5, subtract 9. Negative 5 to negative 18, subtract 13. Negative 18 to get to negative 35, subtract 17. Second difference, negative 5 to negative 9, you subtract 4. You subtract 4, subtract 4. So, an n squared sequence with a coefficient of negative 2. I took the half of negative 4. So remember what an n squared sequence goes. It's 1, 4, 9, 16, 25, etc. So we're going to multiply those numbers by negative 2. Negative 2 times 1 is negative 2. Negative 2 times 4 is negative 8. Negative 18, negative 32, and negative 15. Let's subtract, and again, let's put this in parentheses because otherwise we get confused. 9 minus negative 2 is positive 11. 4 minus negative 8 is 12. 5 minus negative 18 is 13, 14, and 15. So our expression, our answer, so far is made of negative 2n squared. There's another sequence inside here, right? Part of that is the negative 2n squared. Now, take the first difference again. This one's plus 1, plus 1, plus 1, plus 1. So the coefficient in front of the n is just 1. What's the first 5 terms in a 1n sequence? Well, 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times 5. Subtract. 11 minus 1 is 10, 12 minus 2 is 10, 13 minus 3 is 10, 14 minus 4 is 10, 10, 10. So our nth term is this, with this, with this. So negative 2n squared plus n plus 10. So we did 8. Now, when will this equal negative 1,215? All right, so as of now, I would just, instead of factoring or doing, I would guess and check. Let's say n is, right, when would this gives you 1,000, negative 1,000? I would use, let's see. 25 squared is 625. Let's try 25 when n is 25, and then we'll adjust. So when n equals 25, when our term is 25, will our answer be negative 1,215? Well, let's substitute. So it's negative 2 times 25 squared plus 25 plus 10. 25 squared is 625 times 2 is 1,250. Negative 1,250 plus 25 plus 10. Well, this is negative 1,225 plus 10 and negative 1,215. Oh, look at that, the first try. So when n equals 15, what term has a value of negative 1,215? It is when n equals 25. You can do a little guess and check. All right. H, same thing. Find expression. All right, so 7, 16, 29, 46. First difference, 9, 13, 17, 41. Second difference is going to be 4, 4, 4. So our coefficient in front of the n squared is going to be half of 4, which is 2. It's 2n squared. Now, let me write these numbers down. You should by now know that by heart. So we're going to take 1, 4, 9, 16, 25, 60, 25, 36, and multiply it by 2. So we're going to get 2, 8, 18, 32, 50. Let's subtract. Put that in parentheses. 7 minus 2 is 5. 16 minus 8 is 8. 29 minus 18 is 11. 14 and 17. Alright, so our expression, our nth term is 2n squared. There's a little bit more to that. Let's find again first difference. Plus 3, plus 3, plus 3, plus 3. So our coefficient in front of the n is going to be 3. And the 3n sequence is just 3 times 1, 3 times 2, 3 times 1, 3 times 2, 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. So think about it. How do I make this sequence of 3, 6, 9, 12, 15 get to 5, 8, 11, 14, 17? I would have to add plus 2, right? So if you do 5 minus 3, you get 2, 2, 2, 2, 2. So our nth term is made up of these 3 parts, plus 3n, plus 2. Now the second question, so that's the answer for A. Part B is asking, when will this equal 862? 25 might be 625. 25 would be too big of a number. 20 is 400. Let's try 20. Right, when our nth term, when n equals 20, will it give you 862? So 2 times 20 squared plus 3 times 20 plus 2. Well, let's see. 2 times 20 squared is 400. 3 times 20 is 60 plus 2. 2 times 400 is 800. Oh, look at that. So we're correct. Find a term. So when the first term was 7, the second 16, the third was 29, the fourth was 46, the fifth was 67. The 20th term will have a total of 862. Okay. Now that you have these two methods, you can choose, for example, for this problem, whether you want to do the old-fashioned way when we did it in class, right? Trying to figure out how this grew, and or you can do first, second, third difference. Well, this is the first term, this is the second term, this is the third term. So the first term has how many? 2. So the first term in our sequence is 2. The second term in our sequence is 8. The third term in our sequence is 2, 3, 4. 1, 2, 3, 4, 5. So 20 minus 2 is 18. 2, 8, 18. We took the first difference here. This was what? Plus 6. This was plus 12. So we can guess that the next one would be 6, 4, 14, which would make this 32. 6, 10, 14, and in order, so think about this, right? 2 plus 6 would give me 8, 8 plus 10 would give me 18, 18 plus 14 would give me 32. So the next term in our sequence would be 32. And then I can continue. I say we need to find a second difference, which is 4 and 4. Now we have a quadratic sequence in here. Our coefficient is going to be half of 4, which is 2n squared. 2n squared would be 1 squared times 2, which is 2. 2 squared, which is 4 times 2. 3 squared, which is 9 times 2 is 18. And 4 squared, whoa, look at that. Parentheses, if you subtract, you get 0, 0, 0, 0. So this particular, the nth term for this sequence is just literally 2n squared. That's it. Jane says that 75 is a term in the quadratic sequence. So if you were to continue this, right, so we had the 2, 8, the 18, the 32, and so forth, and Jane is saying that 72 would be in this sequence. Is she correct or not? Well, if 75 is in this sequence, then we could take this, right, 2n squared equals 75. So we know that this is the first term, the second, the third, the fourth. Well, if 75 did work, we could find n. Well, one way of doing that is to divide by 2. N squared equals, what's 75 divided by 2? 37.5. Sorry. Yeah, 37.5. And if we take the square root of both sides, there's not going to be a an answer that is rational. It's going to be an right? So 75 is not a term in this sequence because it just doesn't work. Okay. And you could have done this by continuing the pattern if you wanted to. Right, plus 16. The next one will be plus 18. And the next one will be plus 22. And see if 75 would show up in this, which it wouldn't. So that could have been one way. Another way you could have done it. So remember, that's the nth term, but you can write the nth term in this way, right? Y equals 2n squared, which this represents the total number of tiles, total number of little squares. So they're saying that when the total number of squares is 75, right? What is n? And that's what we just did. We would try and look for the value of n. What is n? The 8th term, the 9th term, the 10th term, etc. But in this case, there wasn't one. All right, so with this one, and again, now you have choice, right? When we do this, you have choice. You can either see how it grows and do it visually, or you can write the total number. So we get 4 over here. We get 4, 5, 6, 4, 7, and this is, sorry, 1, 2, 3, 9, 10, 11, 12. Took the first difference. This is 3. This is 5, and you can guess that the next one will be 7, which would mean that the next drawing, the next term, would have 19, right? Would have 19 little squares. And then if you took the second difference, you'd be 2, 2, etc., and 2. So our coefficient in front of n squared is 2 divided by 2, which is just 1. This one's easy. That's an n square sequence. By now you should know 1, 4, 9. Excuse me, 16. I'm going to subtract, put that in parentheses. We're left with 3, 3, 3, 3. So this, well, there's no point of, there's no sequence left over. It's just the same 3, 3, 3, 3. So there is no sequence. So that means that for this particular pattern, the nth term is n squared plus 3. So if you think about it, 1, 4, 9, 16, 25. If you took 1 squared and then add 3, would you get 4? And if you took 2 squared, which is 4, and add 3, do you get 7? If you took 3 squared, which is 9, and you add 3, do you get 12? Yeah, so this one works just fine. Okay. This one is easy. If you, right off the bat, you can tell that it's these 3 repeats over and over. So if I were to draw the next picture here, I will have green, the yellow, and the blue again. And if you notice the base, this was 1, this was 4, this was 9. So the base here, this guy over here, would be 16, right? So it's plus 4, right? So the plus, sorry, not plus 4, plus 3 repeats over and over and over. And what's the base? Well, that's the first term, the base is 1. The second term, the base is 4. The third term, the base is 9. The fourth term, the base is 16. So it's n squared, right? So if you take the term and you square it and then add 3, you get the number of cubes. So n squared plus 3. You could do that visually, or if you wanted to, you could say this is 4, this is 7, this is 3 and 9, which is 9 and 3, which is 12. So if you took the first difference, this was plus 3, plus 5, and the next one will be plus 7, which makes this 19. Yeah? If you take the second difference, it would be 2 and 2. So now you have a choice of doing it visually or writing out the sequence and doing the first and second different method. So divide 2 by half of 2 is 1, so we know that our coefficient in front of n squared is going to be 1. And then we substitute 1, 2, 3, 4, and we get 1 squared times 1, 2 squared times 1, 3 squared times 1, and 4 squared times 1. Subtract, 4 minus 1 is 3, everything is 3. There's no sequence here because it's just 3, 3, 3, 3. So just like we got before, so our answer is made up of this and this. And the last question, I think. Well, let's count. There's 1 cube here. There is 1, 2, 3, 4, 5, 6. There's 6 cubes here. There's 1. There's 1 at the top. There's 5 in the middle. And 5, right? 5, 6, 7, 8, 9, 10, 11, 12, 13. So our numbers are 1, 6, 13. Let's say if you take the first difference, that's 5, that's 7, and you can guess that this one is 9, which would, if we were to draw the next one, it would have 22 cubes, right? So now we take the second difference and we get 2, 2, and 2. So our coefficient in front of n squared is half of 2, which is just 1. So we can write that. So now, 1 times, well, let's substitute 1 squared times 1 is 1, 2 squared times 1 is 4, and then 9, and then 16, and so forth. Let's subtract 1 minus 1 is 0, 6 minus 4 is 2, 13 minus 9 is 4, 22 minus 16 is 6, so there is another sequence here. Take the first difference. 0 to 2 is plus 2, plus 2, plus 2. It's a sequence that goes by 2, otherwise known as 2n. We're going to go 2 times 1, 2 times 2, times 3, 2 times 4. Then in parentheses, subtract 0 minus 2 is negative 2, 2 minus 4 is negative 2, 4 minus 6 is negative 2, and 6 minus 8 is negative 2. So this, along with this, along with this, makes up our nth term. So n squared plus 2n minus 2. And I think that's it.